Transfer learning with pre-trained CNNs. Transfer learning with pre-trained CNNs is a powerful technique that leverages knowledge learned from large datasets to improve the performance of models on tasks with limited data. In this approach, a pre-trained CNN model trained on a large dataset such as ImageNet is used as a feature extractor or as a starting point for training on a new data set or specific task. Let's delve deeper into transfer learning with pre-trained CNNs. First topic is all about overview of transfer learning. Transfer learning involves transferring knowledge from a source domain, usually a large data set, to a target domain, a smaller data set, or a specific task. In the context of CNNs, this typically means using the learned features from pre-trained models to improve the performance of models on new tasks. The second one is benefits of transfer learning. First one is improved performance. Pre-trained models have learned rich feature representations from large dataset which can generalize well to new tasks. Second is faster training. Transfer learning often requires less data and training time compared to training from scratch as the model starts with pre-learned features. Third one is robustness. Pre-trained models have been trained on diverse datasets, making them more robust to variations and noise in the data. The third part that we'll go over is the transfer learning strategies. There are two common strategies for transfer learning with pre-trained CNNs. First one is the feature extraction. In this approach, the pre-trained CNN model is used as a fixed feature extractor. The convolutional base of the pre-trained model is frozen and only the fully connected layers or a few additional layers are added and trained to the new dataset. Fine-tuning. In fine-tuning, the pre-trained CNN model is used as an initialization for training on the new dataset. The convolutional base is fine-tuned along with the additional layers added for the new task. Fine-tuning allows the model to adapt the learned features to the specific characteristics of the new dataset. Fourth one, implementing transfer learning with TensorFlow Keras. Implementing transfer learning with pre-trained CNN in TensorFlow Keras involves the following steps. The first one is load pre-trained model. To load a pre-trained CNN model such as a VGG, RESTnet, Inception, or MobileNet using tf.keras applications is here as explained below. Base model is equal to tf.keras application VGG16. Now we pass these parameters which are weights, which ImageNet include top equal to false and input shape equal to 224 to 24 by 3, the parameters of the image set. Next step is feature extraction. Freeze the convolutional base of the pre-trained model and add custom fully connected layers on top of the new task. This is what you can do by saying first base model trainable equal to false, so you're freezing the model. Next, model equal to sequential, you pass the base model, you call the flatten function, you call dense function with 255 and activation equal to relu, and dense with 10 and activation equal to softmax. Next step is fine tuning. Fine tune the entire model or a subset of layers on a new dataset, optionally using a lower learning rate for the pre-trained layers. You do that by saying again base model.trainable equal to true. Fine tune at 100 for layers in base model.layers. So go over each and every one. Fine tune at use the parameter and then say layers.trainable equal to false. Next step is train and evaluate. Train the model on a new dataset and evaluate its performance on a separate validation or test dataset. You can do that by calling the compile method and pass it optimizer Adam loss function equals parse categorical cross entropy and matrix is accuracy. Then you fit by calling the fit function, train the dataset, give the epochs of 10, validation data is equal to validation dataset. Next, test loss and test accuracy you can get from calling the evaluate function and pass the test dataset. Fifth one is choosing the right pre-trained model. The choice of pre-trained model depends on factors such as the size and nature of the target dataset, computational resources, and the specific characteristics of the task. Experimentation with different pre-trained models and transfer learning strategies is often necessary to find the optimal solution. So transfer learning with pre-trained CNNs is a valuable technique for leveraging knowledge from large datasets to improve the performance of models on new tasks or datasets with limited data. By following the steps outlined above and experimenting with different pre-trained models and transfer learning strategies, you can effectively apply transfer learning to a wide range of computer vision tasks and achieve superior performance with less data and computational resources.